Welcome to this explainer. I want you to just look up at the night sky for a second. For millennia, humanity has stared into that infinite dark, desperately trying to decode the clockwork of the cosmos. And as empires expanded across continents in the 16th century, a massive new frontier awaited exploration right above our heads. But here's the thing, the story we usually tell about this era is missing one of its most brilliant chapters. Today, we are exploring the life of an absolute visionary, a scientist who sought to measure the universe with a level of accuracy rarely seen before his time.
It's a staggering thought, isn't it? What if, while Europe was busy celebrating the age of Nicholas Copernicus and Tycho Brahe, an Ottoman scientist was secretly building revolutionary instruments? What if he was designing highly advanced clocks and observing the heavens with unprecedented precision, rivaling, and honestly, even surpassing, the leading astronomical institutions of the entire world?
Meet Taqi al-Din Muhammad ibn Ma'ruf. Born in 1526, he wasn't just an astronomer. He was a true polymath, an expert in mathematics, engineering, mechanics, optics, and timekeeping. His sheer interdisciplinary genius allowed him to pioneer technologies that wouldn't be seen again in the West for decades, and sometimes even centuries. He is without a doubt a titan of science, and his quest to perfectly measure the universe completely transformed the way we understand our place in it.
Okay, let's dive into this. Part 1, The Forgotten Ottoman Genius. To truly understand his brilliance, we have to set the scene. The 16th century Ottoman Empire was at its absolute height. It was an incredible, booming scientific frontier, and Taqi al-Din's rise within it was nothing short of meteoric. Born into a scholarly family in Damascus, he eventually studied advanced mathematics and astronomy in Cairo. And his dedication to pure, uncorrupted data was so intense that while serving as a judge in Egypt, he actually conducted celestial observations from the bottom of a 25-meter-deep well just to avoid atmospheric distortion. I mean, that is dedication. By 1571, his reputation had reached the capital, and he was appointed chief astronomer of the Ottoman Empire in Istanbul. Part 2, The Greatest Observatory.
So Taqi al-Din knew that the existing astronomical tables of the era were deeply flawed. To fix them, he needed scale. He needed perfection. And with the backing of Sultan Murad III, he got exactly that. In 1577, he established Dar al-Rasad al-Jadid, the new observatory. For a brief, shining moment, Istanbul became one of the world's absolute greatest centers of astronomical research. And this wasn't just a single building. It was a massive complex perched right on a hill overlooking the Bosphorus. It housed 16 full-time staff members, a vast scientific library, and most importantly, a dedicated workshop for fabricating unprecedented, highly precise observational instruments.
To give you a sense of the staggering scale of this operation, just consider the number 6. That represents the 6-meter radius of his massive brass mural quadrant. By building instruments this colossal, Taqi al-Din practically eliminated mechanical deflection and thermal expansion. An instrument of this sheer size absolutely dwarfed earlier European efforts and allowed for a jaw-dropping level of angular resolution.
Now, what's really interesting here is the sheer variety and structural rigidity of these tools. His armillary sphere featured rings measuring over 4 meters across. He custom-built a framed sextant specifically to measure the distances between stars, just to verify Ptolemy's ancient data on Venus. He even built the azimuthal semicircle, which allowed simultaneous tracking of celestial azimuth and altitude, which is essentially anticipating the modern theodolite. These weren't just tools, you guys. They were mechanical masterpieces designed to entirely eliminate human error.
Part 3, Mastering Time Itself.
To map the heavens perfectly, Taqi al-Din knew he first had to conquer something entirely different: time itself. In the 16th century, clocks simply weren't accurate enough for real science. But he wrote, "We built a mechanical clock with a dial showing the hours, minutes, and seconds, and we divided every minute into 5 seconds." By achieving this, Taqi al-Din was able to do what ancient giants like Ptolemy had explicitly failed to do.
This was a monumental shift in the history of science. Instead of relying on static, geometric angle measurements or wildly inaccurate water clocks, Taqi al-Din brought high-precision mechanical engineering into the astronomer's toolkit. He introduced dynamic time measurement into his observations. He could track the exact second a star crossed the meridian, and this methodology made his data wildly more accurate than anything his European contemporaries were doing.
Part 4, Engineering and Optics. Let's move on and see how this all builds together, because you don't just wake up one day and invent a precision seconds clock out of thin air. Taqi al-Din transformed engineering into a vital tool for scientific discovery. Take his 1559 design for a 6-cylinder monoblock water pump. A water wheel turns a camshaft. Those offset cams lift connecting rods in a specific, staggered sequence. Then, heavy lead weights push the pistons down, creating a continuous vacuum suction. This remarkably sophisticated design absolutely astonished historians because it essentially anticipated the inline configuration of modern multi-cylinder engines hundreds of years early.
And if that wasn't enough, get this. In 1551, decades before the European pioneer Giovanni Branca, Taqi al-Din described an early functional steam turbine. He used a directed jet of steam to turn a vane wheel that powered a self-rotating spit. He was casually experimenting with steam power while Europe was barely scratching the surface of the concept.
His brilliance naturally extended into optics, too. He formulated complete laws of reflection and firmly proved the intromission theory of vision, the fact that light reflects off objects into our eyes. And how did he prove it? Using astrophysics. He brilliantly deduced that if our eyes emitted light to see, it would take years for that light to reach the distant stars. But since we see stars the very instant we open our eyes, light must travel from them to us. It's just a beautifully elegant deduction. He even designed an early rudimentary telescope.
Part 5. A legacy beyond empires.
So the crucial point is, what happens when all these disciplines, engineering, optics, horology, mathematics, culminate back at his observatory? The results were stunning. When calculating the annual motion of the solar apogee, which is a highly complex astronomical measurement, Nicholas Copernicus calculated 24 arcseconds. Taqi al-Din calculated 63 arcseconds. The actual modern value? 61. Taqi al-Din's math didn't just compete with the greatest names of the European Renaissance, he actively beat them in accuracy.
And this highlights perfectly why his multidisciplinary approach matters so much. It wasn't luck. He achieved this through the flawless combination of his custom mechanical clocks and rigorous mathematics, like Alberoni's three-point observation method. This synergy of disciplines created a brief, shining zenith of Ottoman science.
But tragically, this golden era was cut incredibly short. In 1577, a great comet appeared over Istanbul. It was observed day and night at the observatory, and initially it was interpreted as an omen of military victory. But when that prophecy failed to materialize amidst some very tense, shifting political conflicts at court, the Sultan ordered the observatory entirely demolished in 1580. After just a few years of operation, the greatest scientific facility of its age was reduced to absolute rubble.
Yet Taqi al-Din's legacy flat-out refused to be buried. While his massive brass instruments were destroyed, his incredibly detailed manuscripts survived. They preserved his revolutionary use of decimal fractions, his highly accurate trigonometric tables, and those incredible engineering designs. His texts circulated, influencing generations of scholars and preserving the hard proof of his sheer, undeniable genius.
As one historian perfectly captures it, the story of Taqi al-Din is not merely the biography of a scientist, it is an epic that tells of the intellectual zenith of the 16th century. His life is not just a tragedy of lost potential, it is a soaring, epic testament to human curiosity and cross-cultural scientific brilliance.
So, to wrap up, what should you take away from all this? Taqi al-Din built one of the absolute most advanced observatories of his era. He revolutionized observational methodology by being the first to effectively use mechanical clocks for astronomy. He was a master engineer who designed a 6-cylinder pump and an early steam turbine. And ultimately, his data actually outperformed his most famous European contemporaries. He rightfully and without a doubt deserves a place alongside Brahe, Kepler, and Copernicus. Which leaves us with a haunting, incredible question. If his observatory hadn't been destroyed in 1580, if Taqi al-Din and his brilliant team had been allowed to continue their work for decades, how much sooner might humanity have unlocked the secrets of the cosmos? It's a fascinating thought, isn't it? And it reminds us that the history of science is filled with these hidden giants just waiting to be rediscovered. Thank you so much for joining me for this explainer on the incredible life of Taqi al-Din. Keep questioning, keep looking up, and stay curious.